Hi guys, this is a SeaSPRITE Python final project. My name is Blesson,
Elizabeth.
My name is Jabbar.
and this is for fall 2025. So background, this project serves two purposes. It fulfills the requirement of our final Python final project while directly integrating into our engineering capstone and developing in partnership with the Naval Surface Warfare Center.
This zone is a multi-semester engineering initiative modernizing the existing Glide educational platform, replacing its original wired controller with a fully engineered wireless control system.
This is a really cool project because it allows us to watch our code cross from the digital domain into the physical world because we're using microcontrollers. So we're making motors spin and turn, and we're causing the microcontrollers to communicate wirelessly. And so everything that we put into code, we can actually see in real life, which is what made this project particularly exciting.
So the hardware.
We we rebuilt this boat's entire electronics using a programmed ESP32 microcontroller. We wrote custom code to handle wireless communication, PWM speed control, servo steering, and the H-bridge motor driving. The H-bridge supplied high current power to the motor and allowed for forward, reverse, and variable speed. It also controlled the servo, the rudder for steering, and separating the logic power from the motor power and writing our own firmware. We were able to create a fully programmable, remotely operated vessel.
So this is the hardware for figure one, the boat itself. As you can see, this is the ESP32. This is the boat itself, the H bridge, and the battery, which is 7.4 volts. This is the over um, figure, and let's go in depth. This is the ESP32. It is pinned. This is the H bridge. This is the 7.4 volts that is connected to the boat. And this is the joystick. Inside of the joystick is a Hall sensor. It detects magnetic fields and converts them to electrical signals. Yeah.
Okay, so for this project actually was, there were two parts to it. So the first part was that we had to design the hardware, and we were augmenting both a controller that was designed by a previous class and a boat that was commercially available, a small RC boat. And the second part is that we had to come up with code that would allow us to sort of marry these devices and make them work together. So this is a 4 month long project that we've been working on that actually started prior to the assignment in our Python class. So we were able to flesh out a lot of issues. And, interestingly enough, the coding and the hardware aspect of it worked hand in hand. So we had to develop the code and the hardware at the same time in order for them to work. So in the previous slide, we pretty much have a batch of code for the controller, and in this slide, we have a batch of code for the boat. And so both devices are using, they're called ESP32 microcontrollers. And so, we know that a microcontroller is, it takes an input and it changes it into an output. And so for these controllers, these microcontrollers, there are Bluetooth and Wi-Fi modules. And part of our project was deciding which would be the most effective communication protocol. The boat is operating near water, so we know that it is a little suboptimal for both, but the limitations of our project pretty much pushed us into using Wi-Fi. And so on the first code for the controller, we call on the Wi-Fi module in our include line, and we pretty much activate it, and we set up the microcontroller as an access point. the microcontroller will also read the Hall sensor. And so what the Hall sensor does is it swings back and forth past a magnet when the controller or the joystick is being used. And there's two microcontrollers. I'm sorry, there's two Hall sensors. So there's one for the X-axis, there's one for the Y-axis. And so there is a loop in this code that actually allows the Hall sensor to, or I'm sorry, the microcontroller to continuously read the Hall sensor readings, and it transmits them wirelessly to the second ESP32, which is connected to the boat. And then we instruct the boat to process those values as forward and back, and also angles for the motor to the servo motor. So this code is it's relatively simple, and I think some of the challenges that came from it was trying to figure out the aux pins on the microcontrollers, and also learning how to set up an access point for Wi-Fi. But ultimately we were able to make the boat work using the wireless controller, and that was the entire objective of our project.
This is the circuit schematic for our boat and our motor and ESP32. Again, this is for the boat itself. As you can see, this is the ESP32's circuit. It's connected to the H bridge, which is connected to a DC motor, and everything is grounded. Uh, this is the servo circuit. It's connected to the ESP32. Um, but this is the basic circuit of the boat.
And the other chart is currently being developed. So this is only one side. This is for the boat side, but for the controller side, we're currently we're drawing out the schematic for it. So it's not, we don't have it in time for this project. We just thought we'd include it so that you could sort of see how things work. And interestingly enough, even though this is a coding project, these pins were completely instrumental in making the boat work. So we thought it would be interesting to put it here after the code. So in this video, you can see that the controller is making the boat work. It does, just the angle of the video, it's kind of hard to see, but it's working wirelessly. So the boat is not connected to the controller at all through any wires. And you can see the microcontroller flashing. When the blue lights are flashing on both microcontrollers, that means that the wireless modules are working as intended, as we called upon in the code. And so we have a successful project here. Some of the challenges we faced were, it was hardware in the beginning. We were trying to, we had to get the boat taken apart, and we had to, engineer it backwards. We had to get the controller working. That was a little difficult because the controller was built by the prior class, so we didn't really have any instructions. We had to figure that out. And then the coding was actually a different beast, and we spent hours and hours, uploading code and uploading and uploading and editing and, trying to get it perfect. So, I think this represents many, many, many hours of hard work. And, being able to see it work is really exciting for all of us.
The annoying part was for me itself was connecting the boat and the Wi-Fi. Sometimes the Wi-Fi wasn't properly working, or the ESP32 is not correctly pinned, and the computer is not connected to the ESP32, or the ESP32 is not properly working to the computer. So that was a different challenge for me too. But this
My
is our
biggest challenge is probably connecting the battery to be able to power the ESP32 alone without it be plugged in and be able to program it any wires and just solely the battery.
Awesome.
And this is the reference and links to the GitHub.